Now, there's often more than one way to do the same thing, but in the interests of saving time and making sure we don't make mistakes, it's really smart to use your log laws to tidy up or simplify an expression before you differentiate it, because it will just make it much easier to do. So this is a quick revision of your log laws. You don't need to write these down again if you know them like the back of your hand, but if you're rusty, jot them down again. Remember that we basically can split up the log by taking its factors and adding the parts separately together. This makes sense because a log is a power, and the only time we add powers is when we are multiplying the bases. Similarly, the only time we subtract powers is when we are dividing the bases. And down here we have the power law. We know that this number can float down the front or vice versa. So here's a few examples. Now in this first one, we can simplify this by noting that the thing that we're taking the log of is 7x squared, and that's made up of 7 multiplied by x squared. So we can rewrite the question before we differentiate and say that we have the log of 7 plus the log of x squared. Now if we want to, we could even change this part to say we've got 2 lots of the log of x, because that too can come down the front using the power law. But I think leaving it like this, there's some extent to which you say there's no point oversimplifying, because the time it takes me to do that, I could already have differentiated it. But this is now much simpler having removed the 7. Now I can see that this is just a number or a constant. So when I go to differentiate one term at a time, I can completely ignore this whole first section. And the second section, I put the x squared down below, and I differentiate it and put that on the top, which gives me 2x. And then it's nice and easy to simplify that and say that I've got 2 over x. Somebody else might have chosen to actually write that next line and say I've got this plus this. And so then when they went to differentiate, they would say I'm going to leave this part, but for this part I've got 2 lots of 1 over x, and they would have jumped straight to the answer there. So either way, there was sort of 2 lines to do. Some people might even do this part in their head, but just make sure that when you're taking a shortcut, it's not one that might lead to a mistake. More than one way of doing things, you'll find your own style, and it might change depending on the question and just what you feel like doing. There's plenty of variety. This next one, I can see that I can use the power law straight away. So let's rewrite this function so that it looks like, I probably don't really need the brackets there, just a little dot. 5 lots of the log of 3x minus 7. Now this part's nice and simple to differentiate, and my 5 is now just a constant that's been multiplied by it. Notice that when we had a constant plus something, we ignored the constant, differentiating one term at a time. But this is one term. So when we differentiate it, the constant stays there. So I'm going to have 5 times, and when I differentiate this part, I need the function on the bottom, if we call that f of x, and f dash x, or 3, on the top. Then it's a simple matter of just tidying it up. I've got 15 on the top and 3x minus 7 on the bottom. For this last one, we've got the log of a quotient here. So we don't want the quotient rule. The quotient rule is when you've got one entire function with x's in it divided by another function with x's in it. We've got the log of a term here. It's just quite a complicated term. So if we can tidy it up, then we can do it one term at a time. So this is the same thing as the log of 1 plus x minus the log of 1 minus x. And I'm using my log laws there to divide this up. And the only time that we subtract indices is when we're dividing the bases. Now it's fairly straightforward to find dy dx. Dy dx equals, now I need to differentiate what's in the brackets here, 1, over what's in the brackets itself, x plus 1 or 1 plus x, doesn't matter. Then subtract, now over here I need to differentiate what's in the brackets. That'll give me minus 1, won't it? So it's up to you. You can write a minus 1 here over 1 minus x, or if you've already seen what's going on and noticed that we're going to have minus and then another minus there, it's nice and simple to just say, well, I'm going to get minus 1 on the top. So I may as well just do a negative negative. It's going to make this one a positive. That way you're finished all in one go, and you're on to the next question while somebody else is rewriting all of that just to change two negatives to a positive.